Lesson 6.5, we're going to move into graphing some transformations of both sine and cos curves. So the first thing we'll notice with our equation here, we have A, K, D, and C. We're familiar with those. We've talked about those in Unit 1. We revisited them in the exponent unit in Unit 4. The only difference is that we have the sine here, and it can be sine or cos depending on the graph, and we'll get to that in a minute. But A, we know from before, is the vertical stretch compression. K is the horizontal stretch compression. D is our moving left and right, and C is our vertical translation up down. So nothing really changes in that sense for this unit. Everything is pretty much the same. So A represents the vertical stretch or compression. And it's the same as before. If A is a whole number, it's a stretch. If A is a fraction, then it would be a vertical compression. K, same as before, is the horizontal stretch or compression. D represents the horizontal translation, going left to right. And C is the vertical translation. Okay, so in fact, the A, K, D, and C are still the same things that they were before. But in this unit, dealing with periodic functions, then they take on a slightly different meaning. So what I mean by that is, A, even though it's a vertical stretch compression, when you're dealing with periodic functions, is now referred to as the amplitude. So A represents amplitude, which is still your vertical stretch compression, right? You're changing how much that graph goes up and down. K remains our horizontal stretch compression. That doesn't change. But 360 divided by K, that represents the period. Because of course, as the graph gets longer or the graph gets shorter, that's determining the period, which is your horizontal stretch compression. Going side to side for your translation, it's now referred to as a phase shift. And the vertical translation, what you're moving up or down by, that actually represents the equation of the axis. So even though these variables mean the same thing, they're just called something different for this unit. So let's get into graphing now. If we look at example 1, here's our graph. Y equals half sine 3 bracket x minus 60 and then plus 3. So if we list these, the 1/2, which is the A value, so that's our amplitude. So the amplitude is 1/2. The negative 60 means we're going 60 degrees to the right. So that's the phase shift. So we'll say 60 degrees right. Our vertical translation is the C value, right? So we're going up 3. And then the last one we'll talk about is the period. So the period we see is 360 divided by K. My K value was 3 because that's separated by a bracket in front of the X, same location that the K value has always been. So the period is going to be 360 divided by 3, which is 120 degrees. Now, before we actually draw the transformed graph, I do want to go back and review how you draw like the parent function of the graph. So this is a sine curve because we see sine in the equation. So if you remember for a sine curve, we start at 0. So 0, 0. My next point goes at 360. So I do first dot, last dot, and then middle. I find the middle, which is at 180. Then between 0 and 180, you find the middle at 90, and we go up to 1. And then between 180 and 360, you find the middle at 270, and you go down to -1. And that gives us our 5 points required for our sine curve. And we're going to follow that same process doing the transformed function. So this point here, starting at 0, 0, is now going up 3 and 60 degrees to the right. So if we go up 3, 1, 2, 3, and then each of these markings is separated by 30 degrees. So we go 30, 60. And there's where our graph is now going to start. So from here, we've gone 60 degrees to the right and up 3. The period is 120 degrees. So from my first dot of my graph to my last has to be 120. So 30, 60, 90, 120. That's where my graph ends. And now to get the rest of the points, I have my first dot, last dot, and now middle dot. I put a point in the middle. Then between the first two, I find the middle and I go up by the amplitude. And the amplitude is a half. So between these two, I find the middle, I go up a half. And between the last 2 points, I find the middle and I go down a half. And that creates our transformed graph. Our next example, again, is a sine curve. Amplitude is 2. Vertical translation, we're going down 3. For my phase shift, 120 degrees to the left, because it's plus 120. The period, 360 divided by k. If k is a half, 360 divided by a half is not 180, right? Because we multiply by the reciprocal. So it's actually 720. Now I'm not going to draw the parent function in this case because I'd already done that on the previous question. So we know that we start at 0, 0 for our parent function. I'm now going to go down 3 and 120 to the left. So I go down to negative 3 and I go to negative 120. And I put my first dot there. The period is 720, which means that from this dot, I have to go over 720 degrees for the end of my graph. Now I can do that 2 ways. I could count by 30s and keep going until I get to 720. I could do 720 divided by 30 to figure out the number of squares. Or I could just say that normally if my period was 720, I start at 0 and I end at 720. Now everything is shifted back 120. So rather than ending at 720, I'm coming back 120. So I end at 600. So at 720, I go back 120 to 600. And that point goes at negative 3 as well. First point, last point, now I have to find the middle. So again, normally the middle would be 360, and then I come back 120. So at 360, I shift everything to the left 120, 30, 60, 90, 120. So it would be at 240. So first dot, last dot, middle dot. Now between the first two, I need to find the middle, and I'm going to go up 2 for my amplitude. So if I want, I can count the squares, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I find the middle, 1, 2, 3, 4, 5, 6, and they go up 2. So from negative 3, I go up to negative 1. And then between these two, I find the middle, 1, 2, 3, 4, 5, 6, and I go down 2. So from negative 3, I'm going to go down 2 to negative 5. And I put my point there. There's my 5 points, and I can connect them with some freehand, and there we go. And there's our graph. For question 3, things get a little bit trickier, and this didn't print. I think that's supposed to be, well, we'll say it's a 2. This gets trickier for a cos curve because with a sine curve, your first dot and your last dot occurs at the equation of the axis, right? It's the middle of your graph. Sine curves are a bit easier. Cos curves are a little bit trickier. So let's write in our information here again. So vertical translation, we're going to go up 2. Phase shift, we're going 60 degrees to the right. Amplitude is 2. Remember, amplitude is the distance from the equation of the axis to your maximum point. Amplitude cannot be negative. So even though there's a negative here, the amplitude is still going to be positive 2, not negative 2. The period, 360 divided by k, which is 3. 360 divided by 3, of course, is 120. Now this is going to get a little bit messier because with the cos curve, it's a little bit trickier than with the sine. So we're going to kind of do these in order. We're going to deal with the amplitude, the period, the phase shift, and then our vertical translation. So I'll grab a few other colors here. Now this will get messy, but it will hopefully make sense once we get through it. The first thing I want to look at is the amplitude. My amplitude is 2. So the original cos curve, if you remember, is we start at 1 and 360 degrees and we end at 1. We find the middle at 180, we go down to -1. We cross at 90 and we cross at 270. So when we put in our 5 points, it looks like a V, actually it creates a V, but we don't want it to be a straight line V because it is a curve. So just with freehand, you do want to give it a bit of a curved look to it, like that, as opposed to being a straight V. So the period is 360, the amplitude is 1. My equation of the axis, or the middle of my graph, is here at 0. So I'm going to change the amplitude to 2. So this is where things get a little tricky because my equation of the axis right now is at 0. So I'm not going up 2, right? I'm not going up to 3 and down to -3. My amplitude is the distance from the equation of the axis to my maximum and minimum point. So for an amplitude of 2, I'm actually going from 1, I'm going up to 2 only. I'm not going up to 3. And then this one's going down to -2. Because with that now, from the middle of my graph to my maximum point is 2. From the middle of my graph to my minimum point is 2. So this gives the amplitude of 2. So that's done. The period is 120. So rather than being 360, I now need to shift this back to 120. So my point is going to stay here at 2, but this one, rather than being at 360, I'm going to come back to 120, which is here. I find the middle between those 2 points, and I go down to -2. And the red is currently what my graph looks like. Everything needs to be phase shift 60 degrees to the right. So I'm going to take all 3 points, I'm going to shift everything over 60 degrees. So this point now becomes 3060. This becomes 3060. I find the middle, and I go down to -2. And now my graph is there. As I said, it gets messy drawing graph over graph over graph. And the last thing is a vertical translation up 2. So everything in this graph, all 3 of those points are now being shifted up 2. So this point here is going to go up 2. So from 2, we're going up to 4. From 2 up to 4. And from -2 up to 0. And we have this. So this graph here, where we're sitting on top of the x-axis, is essentially what our graph is. Now, one thing we haven't talked about yet, if we look here, is we have that negative. And when we were doing transformations before, what does that negative mean? It means that there's a reflection occurring. Now for this graph, the reflection is in fact not in the x-axis. It's not like I'm taking this and I'm flipping it down here. When there's a reflection, what's happening is just the max and min points are flipping. It's a reflection across the equation of the axis, not across the x-axis. So if I have, I don't have another color, but what's happening here is we're flipping these. So your max becomes your min, max becomes the min, min becomes the max. And as we flip this, this becomes our final graph. So as you can see with all those steps, it does become confusing graphing over graph over graph. Now there is an easier way to do these, especially when it comes to the cos curve, because as you can tell, the sine curves are a bit easier. So let's take this same equation, y equals -2 cos 3 x minus 60 plus 2. Now, what we were doing here is we were taking the equation and drawing the graph based on the equation. What if we draw the graph first and then put our values in? So what I mean by that is if we take a look at this equation, I know that it's a negative cos, right? Negative cos. So why don't I just draw a negative cos? And then we're going to look at this equation going backwards. So you start at the right-hand side and finish at the left-hand side. The last number, the +2, is the equation of the axis. The equation of the axis is the middle of my graph. So I can put that in. I know that that is going to be 2. My phase shift is 60 degrees to the right. So my first point on my graph has to occur at +60. The k value is 3. So 360 divided by 3 means I have a period of 120 degrees. So from 60, I want to add on 120. So 60 plus 120 means my graph finishes at 180. Then the last thing is the 2, which is the amplitude. The amplitude is the distance from the equation of the axis. So if my equation of the axis is at 2, I add 2. So I finish at 4. I subtract 2, and I end at 0. Then I can take this, and I can now plot it on my grid. So my first point is going to occur at 60 and at 0. My last point is at 180 and 0. Then between those 2 points, I find the middle. I go up to 4. I put my point, and I connect my dots. And that's exactly what we would have here, rather than going through all the steps. If I look at the previous question, question 2, what if I do the same thing where I draw a sine curve? Start here at -3. That's my equation of the axis. Phase shift 120 to the left, so this point is going to occur at -120. K value is 1/2. We talked about the period being 720. So I add 720 on. You add the period to your first point. It means I finish at 600. Then the amplitude is 2. So from -3, for this point I go up to -1, and I go down to -5. And then I could use those points to graph my graph. So let's take a look at that method then, as we look at next example. Now with this, just like before, a quick reminder, there always needs to be a bracket here. And because there is no bracket, we need the common factor. So y equals negative sine, bracket 0.5, bracket x plus, now 45, and we're factoring out 1/2. 45 divided by 1/2 is 90. So in this case, there is no c value, so there's no vertical translation. The phase shift, 90 degrees to the left. The amplitude, there's no number there. but there always has to be an amplitude. In order for it to be a periodic function, it needs to have an amplitude. So if there's nothing there, it's 1. The period 360 divided by a half is, of course, 720. So let's go back and take our scrap sheet of paper. Now, it is a negative sign. Let's try this. It's a negative sign. So rather than going like this, a negative sign is going to be flipped. And if we flip it, it now starts in the middle, minimum point, maximum point, and back to the middle. See how we reflected it. Starting at the end, moving to the left, 0, there's nothing there, which means the equation of the axis, the middle of my graph, occurs at 0. Plus 90 means that we're starting at negative 90. Period is 720. So negative 90 plus 720 means we need to end at 630. Amplitude is 1. So I go up 1 and I go down 1. And we're done. So my first point of my graph occurs at negative 90 and 0. So negative 90 and 0, my first point. My last point is at 630 and 0. I find the middle, and normally would be 720. Middle would be 360. I shift it back 90, 30, 60, 90. I find the middle between those 2 points and I go down to negative 1. So normally I would be at 180. I want to shift it back 90, 30, 60, 90. Go down to negative 1. Find the middle. Go up to positive 1. Connect the dots. Question 5. We want to write the equation for the cosine function. So it tells us that we want cos. So y equals, first thing is the amplitude, which is 5, cos. The period is 720. So if the period is 720, the k value is a half. Because in order to get k, we just reverse the other thing. So k is equal to 360 divided by the period. So 360 divided by 720 gives us a half for our k value. We're phase shifting 60 degrees to the right. So we can say x minus 60. Or you could use theta there as well, because we're dealing with an angle. And vertical translation is negative 6. So negative 6. So to graph, it's a positive cos. So I draw a positive cos curve. Negative 6 is the middle. Phase shift 60 degrees to the right. So this first dot is going to be a plus 60. Period is 720, which means I'm going to end at 780. Amplitude is 5. So from negative 6, I go up 5 to negative 1, and I go down 5 to negative 11. So my first point here is going to occur at 60 and negative 1. So 30, 60, negative 1. I finished at 780, so 720, 750, 780, negative 1. I find the middle. Now the middle would normally be 360. So I go another 60 degrees, 30, 60. And I want to go down to negative 11. Now clearly we're off the grid here. So we'll just eyeball negative 11, somewhere around there. Say that's negative 11. And then we do as best we can freehand to make that look like that. Okay. So 3 graphs here to finish off. Now normally in class I'd have you guys work ahead on these and then we can check the answers and compare them. But clearly we can't do that now, so let's work through these together. So again, cos curve. So what I would do with this is I would draw a cos. Plus 2 is the equation of the axis. Plus 60 is where I start. Period is 360 divided by 2, which is 180. 60 plus 180 means I end at 240. The amplitude is 3. So I go up 3 and I go down 3. And there's my graph. So my first point is going to be at 60 and plus 5. So 30, 60 and plus 5. My last point is going to be at 240 and plus 5. I find the middle. 1, 2, 3, 4, 5, 6 points. 2, 3, and I go down to negative 1. And I connect those. In reality, we only care about those 3 points. I'm not too worried about where we cross the x-axis at. I'm looking for either the 2 maximum points and the minimum or the 2 minimums and the max if it's a reflection. All right, so for the next one, we have a sine curve. So I'll draw myself a regular sine curve. It's not reflected. Middle of the graph is at negative 3, starting at negative 90. There's no k value here in this case, so the period would be the same, which is 360. Negative 90 plus 360 would be, what, 2, whatever that is. Then we put in the amplitude, which is a half. So negative 3, we go up a half. So it'll be negative 2.5. Negative 3, go down a half. Negative 3.5. And then we'll change this because I can't subtract. There, 270. So my first dot is going to be at negative 90 and negative 3. Negative 90, negative 3. I'm going to finish at 270 instead of 240. So 270, negative 3. Find the middle. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6. We put a dot. Then the middle, we're going to go up a half. So we go up to negative 2.5. Find the middle here, go down a half. And there's our graph. For the last one, we have a negative cos. So again, negative cos. Equation of the axis in the middle is going to be at 0. K value of a half. So I'm starting at negative 180. And I'm adding on 720. So 540 is where I'm going to end up. Amplitude is 1. So my first point is going to be at negative 180 and negative 1. So negative 180, negative 1, 540, negative 1. Now the middle would normally be 360. Then I subtract 180. Go up to 1. And then we connect those points. And we're done. So for homework, for some practice on these, just page 384, question number 7. I'm just looking for you to actually sketch the graph. That's all that you kind of need to do. Just what we did here with these 3 examples. Just take the equation and sketch them. I care more about the graph. I don't really care about what the transformations are. You don't need to worry about listing those. Just actually do the sketch of those graphs.